Welcome, everybody, to the webinar Best Practices to Secure and Harden Software Delivery with Spinnaker. My name is Mark Levy, and I'll be hosting today's webinar. I focus on product marketing here at OpsMX. A few housekeeping items first. The session today is going to be about 30 minutes long. We're recording the session. I will send the recording and the slides to everybody. And if you have any questions, please put them in the chat and we'll answer as many questions as we can. A little bit about OpsMX for those of you that aren't familiar with us. Just a quick overview. OpsMX is a continuous delivery solution provider. The solution is designed to safely and securely increase software delivery without human intervention. OpsMX Intelligent Software Delivery is an open, intelligent, automated CD solution that provides deep end-to-end insights and control over your software delivery process. And as you can see by the logos at the bottom of the slide, OpsMX is trusted by leading enterprises worldwide, enabling them to ship better software faster. Check us out at opsmx.com. Now, I'd like to introduce today's speaker. I'm sure most of you are familiar with Gopi. Gopi is our CTO at OpsMX, where he has overall responsibility for machine learning and data processing architectures of OpsMX Enterprise for Spinnaker. Gopi also has a strong connection with our customers and community, the Spinnaker community, leading design and architecture for strategic implementations. He is also a frequent speaker and well-known leader in continuous delivery and in the Spinnaker community. Gopi, how are you this morning?
Very good, Mark. Thank you. And good morning, good afternoon, good evening to everyone. Should we just jump right into it?
Sure, jump on in.
Thank you. All right, let's get into today's presentation. So what we are going to talk about is securing Spinnaker in your enterprise. And the way we're going to do it is quickly give you an overview of existing features in Spinnaker for security. There are a bunch of built-in structures in Spinnaker that allow you to have it run securely. And then we'll talk about the challenges with the implementation of the secure Spinnaker and some of the things that we need to overcome. And we'll go through what the issues that generally we see in the enterprise and how we overcome those. Before we start off on it, to give a quick intro to Spinnaker, probably you guys are all familiar with it, but Spinnaker is an open source multi-cloud delivery platform. It deployed at a large number of enterprises already. It delivers to multiple cloud environments. AWS, all the public clouds like AWS, GCP, Azure, Kubernetes, and also serverless environments. So that's the strength of Spinnaker with all the built-in deployment strategies delivering to these environments. Essentially what that means is that you get the blue-green deployments or rolling updates, and not only with the Kubernetes, but you also get them with other environments like AWS, GCP. One of the core features of the Spinnaker is built for the DevOps delivery. So it has flexible pipeline structures and the collaboration between different stakeholders in the delivery, the developers, testing, and operations SRE. They collaborate in the delivery with providing visibility into what is currently deployed, what's running where, and how they are deployed through the pipelines. It provides the flexibility with integrations and extensibility. So that's another place we would focus a bit more on security and how to secure these integrations and extensions to Spinnaker. All right. So now to give a brief overview on what's available with Spinnaker and how it secures the infrastructure and the delivery. We generally have three different categories. And one is it has a built-in structures for security for RBAC. The constructs of application and the target environments built with accounts, they have their own RBAC. You can have integrations with the Active Directory, use a SAML for groups, and use those grouping structures to specify who gets access to what kind of applications, what environments, read-only versus execute versus update structures. And then it provides the ability to lock the pipelines or lock the clusters. So in the visually, when these pipelines exist in the UI, even for the people who have access to write those pipelines, update them, it allows locking those pipelines. So essentially, if you have a pipeline structure with certain stages delivering with this configuration to a production environment, for example, then you may want to lock the pipeline structure itself. So there are no changes in the configuration or the steps taken in going into the production. And similarly, it provides the visibility into what is currently running in which environments. And typically, for the lower environments like development or QA or staging, you get access to updating these cluster structures, including the number of instances or rolling back those clusters. But in the production environments, it allows you to lock those structures. So you make the changes only through a standard process, not ad hoc way. And there are also Spinnaker deployment supports secrets integration for the Spinnaker configuration itself. This includes using vault or encrypted secrets from Git. And it also provides the ability to generate notifications with these pipelines. Anytime something is executed, deployed a certain place, you get notifications, provides extensive support for monitoring. So in general, it feels fairly strong, secure environment. But what are the challenges with it, right? Generally, we categorize them into three different structures of challenges. One is securing the infrastructure itself, how we are deploying Spinnaker, how we are configuring Spinnaker. And then we have operational security, how we are allowing users to modify their delivery structures and onboard applications onto the Spinnaker. And then the delivery security itself. We will go a little bit more into delivery security on what it actually means and how the secure applications are delivered securely in those environments. And that requires securing extensions and audit for compliance. So one of the, what are these challenges, right? These challenges essentially involve configuration management for Spinnaker and how do we address the vulnerabilities and policies for the deploying of Spinnaker. Let's go right in and see what the best practices in securing, addressing each of these challenges with the existing Spinnaker and what the recommendations are. Okay, infrastructure security, right? So when we are deploying Spinnaker, we are taking Spinnaker images from the OSs and deploying them. Now, these OSs, because Spinnaker itself is OSs, like any other software, it uses a large number of other OSs components pulled in and packaged. It's packaged with the Alpine images. Then these images have a significant number of third-party components, and the base image itself is built on the Alpine. So in some cases, when we want really secure image, you want to pick up the components that are pre-certified. For example, you may have requirements for FIPS. That will require a specific version of a base OS that you run on, ability to enable FIPS for encryption. And so you want to be able to pick those images and build it. And so the other issues that we have seen is these images, when we run on Kubernetes environments, we have additional policy requirements. Say, for example, you cannot run the image as a root user, or you cannot have any of the base volumes that are writable. So then you need to have these additional policies that apply to the base images that we are building the Spinnaker with and have those hardened. There are some gaps in the OSS images for these, and you have to make sure you can apply these additional policies on top of those to harden the base images. And enabling FIPS requires a couple of additional steps that you have to do, ensuring that encrypted libraries that you're including are the certified libraries, and also enable the encryption on top of those things. The biggest one that we see is the vulnerabilities with the images themselves. There is some backlog right now with the OSS images that have some critical vulnerabilities with the deployments. Now, we have to make sure that in the environment, when you're deploying them, you know which vulnerabilities exist and take exceptions to those vulnerabilities so you can track how they are being used. So this has implications on securing your ingress and egress environments, egress ports for your system, and also locking down your Spinnaker environment for this access. Right? And the next one is the encryption at rest and in transit. Spinnaker, as we saw, supports for its configuration connecting to something like a vault and allowing you to secure it. Encrypt your secrets. At the same time, it also supports with the Spring Security a few other configurations. But in your environment, if you have secrets manager that's not natively supported, then you need to add those configuration extensions to the Spinnaker to support those secrets management. The encryption in transit is some of the requirements in more secure environments. You may want to ensure that the communication between the services of the Spinnaker itself is encrypted. Then you can enable the MTLS with the Spinnaker. So this comes with this simple configuration that you can add to the base images when you're building them to say you need that MTLS, and then bring up these instances with a secure communication between the services of the Spinnaker itself. So that's one of the requirements that we have seen where they require encryption in transit as well. And those are some of the things that we can easily add to the deployments. And IAM integration is another way you can secure your system. So typically when we want to access cloud resources, like say, for example, in AWS, you want to access S3 or RDS, you have to provide credentials to it. Instead, if we use the IAM integrated instances with Spinnaker, then we don't have to worry about key rotation or configuring explicit access keys for it. We can use the service account role and then use impersonation, access cloud resources with the policy that's applied to it. This is a much more secure way and much easier to manage without the key rotation requirements explicitly. This is one of the key implementations that most of the organizations are following now. And the last one is the agent-based deployment, which is you may have production clusters that are air-gapped. So essentially, there is no direct access to those environments from outside. So and then you don't necessarily want to run Spinnaker in your production environment to do the deployment to those production clusters. So in those situations, you can have an agent mechanism. So you deploy the agent in the air-gapped cluster, which connects back to the Spinnaker. And now, even without having Spinnaker direct access to the production cluster, you can now deploy to these environments. This is one of the extensions that we have done to these environments and currently in use in some of the organizations that helps them deploy to their staging environments and lower environments, as well as to the production with the same instance, but with added security. Now that we talked about the infrastructure security, let's jump into the operational security. So what does this mean? Right? This essentially means allowing in an organization, typically the Spinnaker is managed by a group that's different from that of a group that actually do the development and operations of these applications. So there are some best practices that you want to follow and allow these groups to use those best practices for delivering their applications. And so these controls, if they're configured with the Spinnaker, that allows the users to then follow best practices. So as we were discussing, securing the pipelines themselves, right? The pipeline construction typically is done through templates. There are 80-20 rule. You have 80% of your pipelines that are very similar to each other, and you can have best practices pipelines that are generated for these groups, which they can use to deliver their application. And for those applications, typically done through the templates, and once they are generated with the templates with parameterized data, you want to have those pipelines locked, so that at least the ones that are going to the production. So these locked pipelines help in ensuring the configuration that is used to deliver to the production environment helps in compliance audit at a later times. Now, if they're already locked, then how do we change these pipelines? This is where Spinnaker's ability for pipeline as a code comes into play. You can have this pipeline as a code in the Git repository and use that configuration in the Git to apply those pipeline structures to Spinnaker. And now you can have these versions available for these pipelines in your Git repository, and any changes get applied to the Spinnaker, and Spinnaker from the UI, those pipelines are locked and there are no changes that are allowed from the UI. So this is a good practice to follow for the production environments, and it saves a lot of headache going forward. The second one that you want to follow is for the production environments, you want to lock the cluster changes as well. Spinnaker provides the visibility into what's currently running in your target environments. It displays all the deployments, microservices that are running, number of instances. You can have access to logs if you want to troubleshoot. At the same time, it also allows you to roll back to previous version or increase the number of instances. So you want to avoid those kind of changes from the cluster view, primarily because it creates a drift in the target environment in the production. Next time, if you run a pipeline to deploy to that environment, the assumption that we're making on the state of the target environment may not be valid. So the changes will not be reflected. For example, if you're running 5 instances in the target, right now and increased it to 7 without using auto scaling, let's say you made the change. As you deploy through the pipeline, that may revert back to 5 instances, which may cause performance issues for it. That's the simplest example, but there are many others like that. So you want to ensure that the clusters are locked there. And the other one is the secrets management. In your applications, the applications themselves have secrets, which are different from that of Spinnaker services themselves using secrets. So typically, if these secrets are applied through the pipeline, then they are visible in the pipeline, which we don't want to do. So what that means is you need to have a mechanism that applies the secrets to the target environment for those applications outside these structures. So how do we do that? Typically, what happens is there is a secondary process where someone applies those secrets to the target environment through a separate environment, or have the integrations with Vault to Kubernetes, which then applies the secrets from Vault to the Kubernetes based on custom resource structures. So if we don't have those, typically what we have done for these environments is a custom stage that can take the secrets in encrypted form. It's similar to, let's say, encrypted : secret name, and then can fetch the secret from the store, something like a secrets manager or a secret store, and apply it to the Kubernetes environment. Then you can apply the regular manifest for the application, which can reuse those secrets. These are done in a couple of ways. One is to as a sidecar to these applications that get attached, or pre-apply these secrets to the environment and then run it. So you need to provide these mechanisms to application groups so they can follow best practices and not have to do two different operations separately for secrets and application delivery. This is one of the most common issues that we run into. So also you have to ensure there is RBAC set for all resources. So Spinnaker by default is open system. So for the application, someone can create without specifying an RBAC. And then it's open for everyone to see. And similarly for accounts also. So the target environments you can create without providing an RBAC. So you have to make sure those RBAC specification is required for these applications and the target accounts. So the way to do that is having a policy or a plugin that's associated with your application, something like a friend 50. These are extensions that we have done that allow you to specify the policies required for your organization. So when anyone creates an application or an account, at that point, it verifies that the RBAC is specified and then can apply that RBAC to it. Anytime an application changes or a account is changing, it does check those policies and make sure the policies are verified for saving them. So this one helps in the onboarding also. In Spinnaker, we allow end users by default to create their own applications and pipelines. But when it comes to create the target environments, there is no easy provision right now. There is some amount of work that is being done to provide an API that allows end users also to onboard accounts into it, but it's currently not available with Spinnaker. So what we have done is provided a layer on top that allows onboarding of these accounts. Usually, the issues that they run into is provide credentials to the account. How do they provide the credentials securely for their own accounts and create these accounts dynamically in Spinnaker that give access to only their group? So this is done through an integration with an application store or a policy manager and provides an API for the end users to specify their account and the namespace. We have to ensure that the namespace that they are providing is accessible to them and their application name, naming conventions or the enterprise requirements are matching. So you essentially check the policies and then create through the API. This is one of the extensions that we have done. It's fairly useful and used in large number of enterprises. And of course, in the operational, you have to make sure the Spinnaker service is highly available and performing. So monitoring is critical, of course, that goes without saying. There is significant number of metrics that are exposed by Spinnaker. And so you can use a dashboards with the specific metrics that allow you to look into what's the performance and ensure there are no errors that are being generated by different services and the availability is high. So that's a lot of information, but hopefully that was easy to grasp. And the last one we will talk about is the delivery security. So what is delivery security? It essentially comes down to, can we ensure what we are building through the pipelines and then deploying adheres to secure practices? So this is not necessarily a function of Spinnaker, but these are the best practices for the secure delivery. Almost all organizations are trying to implement. Part of the change has been in the last year, the number of security attacks that are done on the production systems, which has always been the case for the last n number of years, most of the attacks happen on production systems, right? It's been the case for most of the last few decades. But last year it has changed. The number of attacks now on the supply chain for this software delivery are higher than the attacks that are happening on the production systems. So that puts a additional burden on the delivery chains to ensure the software that is being delivered adheres to best practices and secure. So this is where the best practices for delivering the software comes in. These attacks can happen at many places. So there could be the source code attacks that we are pulling in from open source, including in our systems. It could be wrong, or when we are building the OSS libraries that we are pulling in, can come from incorrect locations, or they could have vulnerabilities in them, which is fairly common. And then when we publish the artifacts to the repository, we may be deploying from incorrect repository, which hasn't gone through all the checks. And there may be policies that we need to follow in terms of, say, some things like Sarbanes-Oxley policies or approval policies that needs to be verified before we can deploy to a production environment. So any of these can happen, and Spinnaker really sits in the middle of it to ensure that the delivery is secure. Some of the obvious things that are being done with the Spinnaker are integrating the security checks as part of the delivery process. For example, the SAST, source code analysis, and DAST, or vulnerability analysis, become part of the Spinnaker pipeline checks, where it ensures that these checks are done, and also the results of these checks conform to a certain policy before it can be deployed into a production environment. And the additional advantage here is that the pipeline structures help the developers find the issues much closer to the development time than the production. So you need to specify these pipeline structures where these checks are done in a way that they're not becoming gate for the development process itself, dev test process, but can be done in the background and verified at the time when they're trying to promote to QA or production, but alert at the time of dev test to say there are additional vulnerabilities in the new build that is done, or the source code scan identified some code smells that need to be fixed. So they need to be integrated with the dev test. At the same time, these tests must be part of the delivery chain, and they can be specified as a process for the enterprise that specifies the required checks in the delivery. And so we can ensure that when we create the pipeline templates, these process integrations are part of the templates. And when application groups create these pipelines, we can verify the pipelines are created with those process integrations. As we discussed, the plugin for Front 50 can check these and ensure that delivery chain is secure. At the same time, at the time of the deployment, we can have a plugin to the cloud driver that verifies that the checks are all done. Because generally the pipeline, there's not one pipeline that goes all the way from Git change of the developer all the way to the production. Typically, they are broken down into 2 or 3 different pipelines. So it may be possible to trigger the last pipeline without having the single chain. So we would need to check the provenance at the time of admission, and we can do that with the plugin to the cloud driver. And obviously, for compliance reasons, you have to make sure the audit is fully covered. Any changes that go into the production environment, including binary changes or the changes to the configuration, are captured. Right? So the alerting and policy checks is very critical because we want to use this as a guardrail and not necessarily as a gate. So the developer experience is really critical in delivering secure software. If they feel that the security is impeding their progress, then the speed of the delivery goes down, or they will find ways to circumvent some of these security checks and speed up their delivery. So alerting and being in the cognizant of the developer experience, having them adhere to the policies is fairly critical. And the extensions are basically the plugins. You have to make sure the same level of security checks are done to the extensions of the Spinnaker pipelines and plugins. All right, I think we are close to end of the time. So we went through the infrastructure security requirements, where the challenges are, and what kind of actions one can take to secure them. Similarly with operational security. Delivery security is more in terms of best practices and what are the things one should do in delivering secure software. It's more than Spinnaker itself, but these are more like a best practices, and Spinnaker supports these extensions. It allows you to do all of this. And we have built in a few of these integrations that come with our own distribution on top of OSS Spinnaker, so it makes it easy for you to provide this delivery security in your environment. That's all I had for today. Thank you for having the patience and listening to the webinar. If you have any questions, I can answer now.
Great, Gopi. Yeah, there's a lot of info in the last half hour, and we'll definitely send out the recording. Any questions, please enter them in the chat. And Gopi, you brought up some really interesting things. I really liked guardrails versus gates. You know, that's a good concept. And this whole idea of where you have organizations that, you know, need to ensure compliance and security and mitigate risk. But at the same time, you have, you know, how do you enable your developers who see that as possibly getting into the way of their job? Right. And maybe that's a cultural thing that, you know, but at the same time, it's something that still needs to be addressed and can be addressed with software. You know, what kind of sort of features and capabilities that you have to enable, you know, your developers to really sort of work autonomously. Right.
That's right. This is a interesting problem. We all think security is critical. Everybody thinks security is critical. But when it comes to delivering faster, at that point, if the security is seen as gating for all the changes, then there is always a pushback a little bit on the security requirements. For example, you may have critical vulnerabilities that exist in the software that can go undetected. So having this process set up in a way, it doesn't impede on the test cycle for the developers. Have them do a faster checks of those, but at the same time provide the guardrails when they are going to higher environment, and giving them the feedback as soon as issues are found really helps with that process. So integrating the security in the delivery process and not having it as a secondary system that gets checked by somebody else is fairly critical in achieving the secure practices, delivery practices.
And it really sort of maintains to the sort of whole DevOps ethos, right? It's, you know, typically security teams are sort of siloed, and even today, they might join a team, but security becomes still a sort of a siloed, you know, function within the team. But I like the idea of positioning this, you know, as delivery security, you know, in context with software delivery. From that perspective, I think provides a much more holistic view of how and a better view of securing, you know, this whole code to cloud, you know, and ensuring for going from code to cloud is secure and compliant.
That's right. And there is also a learning curve with all these practices, right? How do you use static scan results? How do you view this vulnerability results? And each of these components can have hundreds of open source libraries that are being used. And some have new versions that you can easily fix with. Some don't. And how do you surface this data, and how do you also make sure that which vulnerabilities can be taken as exceptions and which are critical? Although the score exists, the score doesn't mean that every application gets affected the same way. So these are all some of the things that part of the best practices and learning that we can provide that to the entire organization once we have the central team or the best practices are put in place.
Yeah,
Makes
great.
it
Well,
easy for that cycle to happen quickly.
yeah, super. Well, any other questions? I know we're sort of running a little late here, so I want to get everyone back to their day. I want to thank everybody for their time today. And Gopi, thank you so much. This is, of course, a very important and interesting topic. I hope you gained something from it. If you have other further questions, just reach out to us. We'll answer any questions offline. Send us an email. And with that, I want to thank everybody and have a good day. Thank you, Gopi. We'll see you guys later.
Thank you, Mark. Thanks, everyone,
Bye
for joining us.
bye.